I think everybody's excited about what takes us to space, which is rocketry. And they actually evolved from fireworks. And then in the 1300s, they were weaponized. In the 1800s, someone started writing about rockets taking us into space for life off Earth. And then after that, in the 20th century, we started seeing that as a reality. There was some music playing with this to make it a bit more attention getting starting off, but we'll manage with that to show the, as you see, there was weaponization of rockets, but then it started moving forward into actually taking things into space, building a space economy. But everything has to be manufactured. Some of these things might look familiar to you, some of the first SpaceX launches, and other players that are coming into the market. You'll see Stoke Space highlighted here, Rocket Lab, Blue Origin, Firefly, and even Astra. Some of the new techniques that are coming into play as well. But manufacturing evolution is a critical driver of how we get to space. That's increasing our launch cadence, increasing design and performance life cycle, support for reuse of launch systems and reuse eventually of satellites through areas that we'll talk about, such as in-space servicing, and then a persistent infrastructure. So one of the most persistent infrastructure so far has been our spaceport system. And then when factories were first built, they were built to build these bespoke systems that maybe that was the only thing that factory did. Now we have more persistent capabilities for that. And then we've also seen cost reductions over time as you manufacture and design both rocket systems and other kit for space. And all of this is fueled also, there's a national interest in space manufacturing and the evolution of manufacturing. It feeds both your national industrial base, your economy, and of course the ties to defense and industry. So real quick, I would like to go through a little story on the past, the present, the past, recent history, the present and near future, and then the future of what we're going to be seeing in space manufacturing. So early on, space manufacturing was quite cheap and quite difficult. What was bleeding edge at the time now seems quite elementary. So we initially needed to use paper drawings and build machine things and even put them through destructive testing. The cost was quite high, and it really required the treasure of a nation in order to enter space. And that happened for quite a long time. The cost of launch was also prohibitive from commercial entering space. And then average satellite size, while they started quite small with Sputnik and others, they did get bigger and bigger. And in the 80s, does anyone know the Milstar satellite? Anyone familiar with the Milstar satellite? It was about the size of a school bus, so that's quite a large. Since it was so expensive to get to space, you would throw everything you could onto it since you're putting so much up. And then now, the tech refresh changes so quick, you've either got to upgrade through software or through hardware, but you're not seeing as many ginormous machines going into space. Then more recently, we started in the 2000s to really the 2020s, we started seeing more commercial entries into the space race, if we want to call it that. And I think we've entered now into the golden age of commercial space, where it's no longer just a playground for nations with the wealth of a nation, but commercial companies are involved. And that's been driven by digital transformation that we have seen, as well as instead of designing your satellite and then saying, okay, how do I get this made and into space, we can actually design for manufacturability of our satellites. And what you're seeing in some of the videos there, these are digital twins of products, of additive manufacturing, of an actual CubeSat, but it's not just the product. You can actually do a digital twin of your manufacturing process, your factory. So when factories first came into play at the start of the space race to build a rocket or a satellite, someone might come into a warehouse this size and some brilliant person could visualize, here's where my supplies come in, here's the flow of the operation, and lay it out, and then out the other side comes my product. Well, you don't have to be that genius now. You can actually build it digitally, and we've developed that over the last 20 years to create a digital twin of your factory and see how that actually works. Run simulations to show where you might have bottlenecks, because as you have a realistic representation of your factory, you can reveal things through simulation that you might not have seen in your initial design. You can see where those issues come up. And I'm sure most of you here are old enough to remember when the Internet of Things was a hot term and was used, and really that's now just data analytics and collecting data on what we have and having things connected. So if you have a device that's not connected now, your device isn't that useful, but it's still useful. Then we've seen additive manufacturing, and machine vision has also come into play in the space area, both in the factories and in actual operations in space. And as we mentioned, data analytics and being able to do predictive analytics is quite important in the space area. So today, I'd like to move on now to look at what we're seeing today. So AI is enhancing design, engineering, and manufacturing across the space industry. Is anyone here not from the space industry, doesn't do anything for space, you're just here to learn more about it? I would think everybody here touches space in some way. Has anybody here not touched AI in some way? I think that would be, if you have a smartphone, you've touched AI. So don't sell yourself short, because AI is touching everything that we do. So today we're seeing mass production as well. You know, you have mega constellations coming up like Starlink, OneWeb, Kuiper, and actually just maybe it was last week, China filed to put up a 200,000 satellite constellation. So you are going to see more mass production of satellites, but not just, most people are still going to be using those smaller number of satellites in a constellation, but you've still got to mass produce your components for that. So you've got your IMUs, you've got just solar panels, all the components that would go into, or your thrusters, your engines, anything that would go in there, they're going to be more mass produced as standardization, while not universal, there's a lot more standard components that you can choose from. One of the great things that you're seeing in those top two videos is AI-assisted design, or generative design. We hear about generative AI. It's where the system is learning what you're wanting and then giving that to you. But we've been doing generative design for quite a while, where we can put in these cases, what you see at the top is a small component. When you're going into space, weight matters. So we tell the system what we want its strengths and tolerances to be, and it can come back and tell us a better design from what we put in. So we can use generative design and AI to assist with that. We can also take a digital thread. So whenever we're using model-based and digitalization, digital ways of designing, digital ways of doing further engineering, and then in manufacturing, and then in operations. When we have an issue in operations or in the manufacturing process, we can trace that through a digital thread to see where the issue is and quickly fix those things. There's also sensors across a shop floor. If you go into a shop floor without any sensors, it's pending upgrade, I would say, because almost everyone has gone through a digital transformation or is trying to go towards a digital transformation to be more efficient. And then what you're seeing in the bottom screen there is actually computer vision and virtual reality assisted manufacturing. So workforce and skilled workforce is always a challenge. And then as our workforce ages and people leave or new people come in, there's a wealth of experience that could be lost. But as we capture this through sensors, through analytics, through just capturing our knowledge and know-how, we can use computer vision, whether it's through a headset or a tablet looking at the device you're manufacturing, and you can be guided by your virtual companion there on how that assembly process should happen, and even look at if it was done properly. Then, now, here's a question for everyone. The difference between a robot and a cobot. Does anyone want to take a stab at the difference between those? So robots have been in play a lot, but cobots, a robot is the machine, say that it's moving apart, and as you get a bottleneck here or something breaks, it just keeps moving parts and piling up and making a mess. But a cobot is actually assisting the human in the loop and thinks a bit more. So think of a co-pilot, but it's a cobot. It's working with you, and it can tell you when something happens. And that's through the connectivity, through having a digital thread, and having some level of embedded AI on each device. You don't necessarily have to be connected to a warehouse-sized cloud to have AI in play. And then, of course, automation increases efficiency a lot. You see it a lot more where there's higher production, like in the automotive industry or other areas, but as we see mega constellations and more standardized, say, thrusters or parts, automation plays a lot more with helping your throughput. And then, if you haven't gone to a panel yet on ISAM, does anyone want to take a stab at what ISAM is? Anybody here familiar with ISAM? I won't say who's not familiar. Okay, so it's in-space service, assembly, and manufacturing. So historically, we've put things into space to be thrown away. When their tank runs out of gas, it gets thrown away. Same thing with rockets. You know, we initially put rockets up, and then they were just disposable. It's as if everybody who flew here flew on the plane, and that plane was thrown away, and you got on a new plane to go back. So we're slowly moving towards being able to service items in space, assemble, and even manufacture in space. So other areas of today, now this is a 4x speed playback, but I wanted to show some of that digital thread in play with manufacturing. This is more on the design side, but this person's in a VR. They looked at the Earth, looked at their constellation, and chose a satellite. Okay, I'm gonna take a look at this satellite. I'm gonna open it up, I'm gonna explode it, and look at my different components within this satellite, and check to see if there's an issue, how are they performing, because there was an as designed, an as built, and as it's operating in space. So you can look at the different aspects, see if there's issues with that sensor connectivity, and then feed that back to your manufacturing process if needed. And you can look beyond just the systems. You can look at its thermal tolerances, its structural tolerances. You know, getting into space is a violent process, so you have to go through a lot of vibroacoustic harshness to get there, so you could see if you made it. Also, and this is showing you can check your electromagnetic performances. One of the things I really wanted to show here is now with this virtual world, you can see the product your satellite is taking. So now put yourself on Earth and say this satellite is providing CO2 and weather data monitoring. So you're now on Earth looking at, here's my winds, here's CO2 emissions for this area, because that's really what's making you your money on your product. You design, engineer, and manufacture the satellite, you put it into space. That didn't make you any money yet. What's making you money is the data you're selling and providing off of that satellite. So if you can see how it's going to work in operations, by having a digital thread, the handoff between all your different processes is much more efficient. Instead of the designer, the structural designer, throwing his design over the wall and giving it to the systems engineer who's also, she's receiving designs from all the different areas and she's got to figure this out. And then the operator gets it. On active duty, I was an operator and I often got kit from space where I said, well, this only does about 1/3 of what I needed to do because the acquirers did trade-off with the engineers and manufacturers and took away capabilities to meet minimum requirements instead of having some of the extra stuff we were really hoping to get. So, and when you're in the military, that happens, or when you're with the government, that can happen. But when you're a for-profit organization, you really want to minimize that, because if you're not given the data that's making you money, you're not going to continue to make money as often. So being able to immerse in your product is very helpful. And we mentioned robots and cobots. One thing that there's a lot of information on this slide, but the thing I wanted to highlight is about in-factory robot demand and how it's doubled in a decade. And in 2025, 75% of that demand was actually in the Asia and Australia area. And the Americas was only 9% of the demand, and Europe was 16%. And that trend is expected to continue. So my vice president of aerospace and defense, he was visiting a client in Korea, and he came back and right away said, you've really got to see the use of cobots and robots, because I went into a factory floor at this client, and there were only a few people. There was a lot of automation in play, and he said that's really the trend is going. And then when I saw this, I said, okay, it makes sense considering Asia has 75% of that effort happening. And then what are the main areas that we're looking at? Well, sensor fusion that we've talked about, that enhances where we're moving forward with robotics and AI. Edge AI and embedded AI. So you know that in order to use AI, if you're using ChatGPT or Grok or something else on your mobile device, you're actually pinging a data center somewhere and getting that processing done, and it's coming back to you. On a shop floor, on a manufacturing operation, you could have embedded AI on your tool, on your kit and equipment to be able to see what's happening in real time and make some decisions on the spot. So you don't necessarily have to use that time to go back to the cloud or lose cloud connectivity. You can have a lot on your shop floor. You can also get real-time response to those controls. The example we made where the robot just kept piling up the error, you could avoid that with some AI embedded into it. And you can get the same thing from satellites. Satellites in the cloud in orbit is got a lot of attention this year, in-space compute, but having some level of AI and compute on board your system is becoming part of the design, engineering, manufacturing process too, to have that capability. And we already talked about cobots and how they are reshaping the modern factory. So what does the future look like? Well, AI is going to be at the core of design, engineering, and manufacturing. I would say it's very much in play right now, but it's going to be critical as we move forward. Also, we mentioned the in-space servicing and assembly. It takes a lot of compute power or onboard AI, because if you're going to do in-space servicing out at GEO, where things aren't, sure they're moving, but they don't appear to be moving, it's easier to touch things at GEO. But when you're at LEO, and there's a lot more going on, especially as more satellites are coming into play. Right now there's about, I think last time I checked, 11,000 active satellites in LEO, but SpaceX is popping up new Starlinks all the time. Does anyone know what the population of the Starlink constellation is right now? Last I heard it was over 7,000, so there's a lot of satellites moving around. That's also, that LEO area is where we're going to be putting the commercial space stations, which leads to the in-space manufacturing. Once we have shop floors and laboratories in space, we're going to see more in-space manufacturing. The video you see playing at the bottom there, in case you missed it, I think it'll loop back, but Varda Space is currently sending up a pod that does autonomous pharmaceuticals and then returns that to the Earth. And that's without having a shop floor or a lab in space yet. And then Space Forge out of the UK is doing the same thing with microchips. So it's already happening, but just at a small scale so far. And then we talked earlier about how we've been throwing things away in space for so long. So in situ utilization of resources. So there's a lot of debris up there that we can eventually, probably not this year, but in the future, be able to harvest and reuse from all the things we put in space to have not just, when we get to the moon, we're talking about lunar regolith, finding water, those things, but just to have mineral resources in orbit, we could harvest what we have up there. Additive manufacturing has also changed things a lot, but when you get into space, additive manufacturing changes as well. Is there anybody here that's an additive manufacturing expert or even pretty smart on it if you're not an expert? Because if we're doing additive manufacturing in this room, it changes when we get into a low gravity environment. And even within the ISS, while you've got some environmental controls there, it changes how additive manufacturing works. So simulation that we talked about, and it's not just simulation of running a simulation, it's got to be a physics-based simulation, because if you run a junky simulation, you're going to get a junky product. But if you have a physics-based simulation that says, this is what I'm additively manufacturing, these are the elements involved, and these are the environmental factors in it, then you'll get the proper product versus just, I showed this device printing out another device, but with no physics involved, well, you're not going to have a very usable product. And then we've talked a bit about AI and compute. Well, most of that is terrestrial right now, and for anything in space that needs significant compute capability, you've got to transmit that back down to Earth. So we're eventually going to see more compute in space. So if it needs to be done in space, compute it in space. Are we going to see a warehouse-sized data center in space? Not anytime soon. There are plans to eventually have those in the moon. If you've heard of Lone Star Data Holdings, they actually launched with Intuitive Machines and put a data backup or data storage on the moon, but we'll eventually get data storage in space, the ability to compute in space, and the ability to do the computing in space that needs to be done, and also embedded AI and data centers onboard systems. So you don't have to transmit down, process, and transmit up. You can get some of that done in space. And so I think this all will move towards a stronger in-space manufacturing ecosystem as we move forward. And innovation will continue to drive these things. If we have this conversation in a year, there may be something that we didn't imagine today. But I think if we have this conversation in 5 years, there's going to be a lot we didn't imagine today. So I appreciate your attention today, taking a look at this. I apologize we didn't have the motivational music in the first slide, but the sky is really not the limit when it comes to manufacturing, and it all has to be imagined, designed, manufactured, whether it's terrestrially for now, but eventually in space, as we put products in space to improve life on Earth and eventually improve life in space and what we're doing there. So I'd be happy to take any questions you have now, or please feel free to contact me, connect on LinkedIn, and I'd be happy to collaborate together in the future.